Hello everyone, welcome to this tutorial. My name is Xarray. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to implement Mann-Kendall analysis for spatial trend analysis in Google Earth Engine platform and XEE library using Python API. In this tutorial, you can estimate if there is any significant trend in your region of interest or not, and then you can estimate the score of the trends for the areas, spatially and temporally. And finally, you will be able to estimate the p-values to understand which areas actually showing significant increasing or decreasing trend. So, if you want to learn this material, follow this tutorial and I will show you how to apply Mann-Kendall analysis in the Google Earth Engine platform using XEE library. In the first step, we want to make a notebook in the Colab environment, and then we need to call necessary libraries to start making connection between Colab environment and Google Earth Engine. Import EE, import GEE map. These two libraries are essential for making connection between Earth Engine and Colab environment. Then import Xarray as XR. The Xarray is a kind of library allowing us to convert the image collections to the Xarray structure. The Xarray structure allowing us to implement machine learning algorithm on raster images. This is very useful. Let's run the first cell and then make a new one. In the next step, we want to install one of the newest libraries, XEE. The XEE is a kind of library allowing you to apply the Xarray on image collections available on Google Earth Engine. This is one of the revolutionary libraries that allowing us to have access to a big range of machine learning algorithm that we can apply them on image collection data, while we couldn't do this process before in the code editor environment. So in this tutorial, I'm gonna show you one of the examples of XEE application in this regard. So as XEE not available as a built-in function in the Python, at least the Colab, so we need to install it first through the pip install EE and then import it into the code. Let's take a few moments. Once the installation successful and installation is done, now you can actually make a connection between Earth Engine and Colab environment. Start with authentication, authenticate, and then initialize your Earth Engine account. Project equals to your cloud project ID connected to your Earth Engine account. To find it, go to the code editor environment. Upper right, you can see the icon of your account. And then go to project info and find the cloud project ID. Copy and paste it into your code. There it is. Very simple. The next argument, OPT URL, related to a kind of URL released by XEE. If you search on the net and about XEE and Google Earth Engine, you will direct to a GitHub page including a complete instruction about how to use XEE and also all detailed instructions about actually conversion image collection into array structure. Now I want to take the OPT URL from here and then paste it into your code. After a few moments, a message popped up asking for permission to connect to Earth Engine. Click on Allow to grant the permission. Select your account, click on Continue, and then Continue. As you can see, without any challenge and without any problem, we made a connection between Colab and Earth Engine. From now on, we can utilize Earth Engine functions in the Colab environment based on Python language. Before going further, we need to identify the region of interest. Imagine we have a variable as map. This variable allowing us to call a function from GEE map library. The function is map. The map make a user interface for you and able us to select the region of interest easily and without any challenge. So the base map in this interface will be satellite view and then print the interface. There it is. Now you have access to a satellite view of globe. Then you can find your region of interest through the zoom in, zoom out, or pan or across the map. Through the draw a rectangle tools available here, you can easily find your region of interest. For example, in this tutorial, I'm gonna study the air temperature changes over 40 years using Era 5 data across Persian Plateau or Iran. So, through a rectangle tool available here, I'm gonna select my own country, Iran, and then I want to actually assign this rectangle to a variable. So make a new cell like this and then make a new variable as ROI. Despite the rectangle created, we need to assign it to a variable because we want to call it in the next step for the further analysis. The ROI equals to from map draw last feature. The last feature selected and then convert it into a geometry structure. So let's print the ROI and now you can see we have a polygon with 5 vertices. There it is with 5 vertices and you can actually see the coordinates for each element separately. So after the region of interest, we need to call the satellite data. This tutorial can be used for all of the time series satellite data. In this tutorial, I'm gonna use Era 5 air temperature product. Go to code editor environment, through the search places on dataset, type your desired data. For example, my data target is Era 5 with monthly frequency. Era 5 monthly aggregates product is available and then click on view dataset option and then you can actually see the description of the data. Through the Earth Engine snippet, copy the image collection ID a new cell into a new cell, make a new variable as collection. Then select the target band. Through the bands available here, I'm gonna select air temperature for 2 meters. The air temperature at 2-meter height from the surface, and the unit of measurement is based on Kelvin, and the spatial resolution is 27 kilometer. This product is available since 1980s to present, and that could be a good option to actually have a long-term change detection analysis. So the next is the filter date. You must filter your data to a period of time. For example, since 1980 to 2025. There it is. And then click run the cell and a collection called here. Let's make a print and see how many images available. We have one image collection with 486 elements. If you open it up here, you can see the all images listed here with one band, the target band or mean 2-meter air temperature data. Okay, now we have an image collection. The image collection is a kind of format we can only use in the Google Earth Engine platform. Now I want to apply the Mann-Kendall analysis, but Mann-Kendall algorithm or Mann-Kendall function is not as a ready-to-use function available in the code editor environment. So I have to use Python libraries to apply Mann-Kendall analysis on the image collection. But there is a problem here because there is an inconsistency between the Python and also Earth Engine script. But thanks to Xee library, from now on, we can convert the image collections to the Xarray structure, and then we can apply the Python libraries, Python functions on the images created in Earth Engine. That's really important things and allowing you to apply the most advanced and the most newest algorithm on the satellite data already actually provided by the Earth Engine. So now I want to do this conversion, a conversion from image collection to the Xarray structure. From XR open dataset, from the Xarray open dataset, allowing us to do this conversion. Which image for a collection, and based on EE engine, I'm gonna do this. Set the CRS to EPSG 4326 and the scale of processing equals to 0.27 kilometer, and the region of interest or geometry equals to ROI CRS EPSG 4326. This is refers to WGS 84 that is same for all around the world. Everything settled, and let's run the dataset. We had 486 elements, and from now on we will have a multi-dimensional data that is available for 486 times or 86 dates actually. Here we have a multi-dimensional format, a multi-dimensional structure. One dimension is time, another one is longitude, and another one is latitude. You can have a quick view to temporal and spatial characteristic of multidimensional array data. And also the air temperature data is available as an array structure. Now with the array structure, we can apply a wide range of algorithm in the Python programming on satellite data. This is very useful things. Okay, now in the next step, I'm gonna call the Mann-Kendall libraries. As the Mann-Kendall is not built-in function in the Colab environment, we need to install it first. Mann-Kendall, there it is. And then import it like this. Import Mann-Kendall as MK. There it is. Let's run. After a few moments, you can see Mann-Kendall installed. This is a library allowing us to apply Mann-Kendall analysis. Okay, in the next step, we need a function allowing us to calculate the Mann-Kendall test based on time series data with Xarray format. Make a new function, but here we want to define a new function here to apply this calculation. The function name is, for example, Mann-Kendall test analysis or something like that. You can choose any other name you prefer. So there is an input in this function. This is an image or array structure, the image with array format. So, and then we want to apply the Mann-Kendall test, a new variable as test created equals to, so from MK library call original test. Original test will apply on IMG. The IMG will be the temperature data with array structure. So the test actually, when you apply Mann-Kendall original test, you will have couple of outputs. If you want to get understanding about the outputs generated by original test, just type the help about mk.original test. There it is. Now through the help, you can have a short description about original test function. As you can see, the output, one of them is trend that tells the trend if increasing or decreasing, or even we have no trend. So, and another one is the p-value. It is very important because the p-value shows the pixels in which the trend is significant. The next is Mann-Kendall score that shows the strength of the change. For example, if the trend is increasing, the S means which pixel the increasing increases more and which pixel increases less. This is very important in comparison. So these parameters are very important: the trend, the p-value, and the S. The trend tells us if there is any trend, P shows the significance of trend, and the S shows the strength of the trend. So now from the test, we want to have trend, for example. Once the test calculated, we want to get the trend output first. And then we want to have the score test.s because the output S refers to the score. And then for the p-value from test output, select P. There it is. But there is a problem here. The test.trend or the trend output only tell us if there is an increasing or decreasing trend. But we want to have a numerical output. This is not numerical. It doesn't have a numerical structure. So we can classify it we can reassign a new value instead of increasing or string expressions. These are string expressions, and maybe we have kind of issues for the visualization. I prefer to convert the strings to the numerical values. This is easier for visualization and interpretation, at least for me. So, how to do this? Now, define trend classes equals to make a dictionary structure and type the expressions such as increasing, decreasing, and no trend. These expressions available in the trend output. So increasing, we need to assign a value to these keys. Increasing is a key, and I'm assigning a value number 1. If there is increasing trend, instead of telling increasing, I'm asking to set a value number 1. If there is decreasing trend, another key, return the -1. And if there is no trend, returns number 0. So there it is. This is a reclassification, but we need to apply it on the trend output. How to do this? A new variable, trend reclass, created. So call the trend class first, and then get the trend image with actually trend class conversions. So in this actually expression, the output return a numerical values instead of string expressions. If there is an increasing trend, you will see value number 1. If there is a decreasing trend, you will see value number -1, and otherwise you will have number 0. So now the inputs, now actually the function is going to return couple of outputs. This time we have a function that returns couple of outputs instead of one. So it is important things, and it's a good technique to learn how you can write a function to return couple of things instead of only one variable. So now I'm returning the reclass trend and score array and p-value array. Let's run. The function is raw and also nothing calculated. This is only a framework that we want to apply on our dataset. So how to do this process? It is very easy. Just thanks to the Xarray and XEE, we can do it quickly. Make a new function as make a new variable, as we will have 3 outputs. Now we need 3 actually variables instead of 1. So for example, finally we want to see the change the trend image for the change, or a score of changes, and also the significance of changes. These are 3 variables equals to, okay, from XR or Xarray, I'm gonna apply Mann-Kendall test. Apply U function as AI assistant addressed here. The first argument related to the created function or defined function, mk test. This is the Mann-Kendall test. And the next one is the dataset name. Dataset select the variable name, the mean 2 meter air temperature. And the next one is, as AI addressed correctly, the next one is input core dimensions equals to time, because we want to monitor the variations over the time. The next one is input core. So, sorry, actually, I think I'm doing something wrong. To make sure if there is any problem here or not, I'm suggesting you to use help. For example, write help and now enter apply u function from XR, apply u function, copy and paste and write it. Now you can see a short description about apply u function, and you can see what kind of arguments you need to have. Input core dimension already defined. The output core dimension is the next one. Let me to hide it. Output core dimension. Output core dimension equals, as we have three inputs, three output also expected. So here, three brackets or three empty list considered for the output core dimension. Okay, the dask or dusk is related to actually helping us to efficient the speed of processing. So, or optimize the speed of processing. I suggesting you to set it to allowed, and then we want to use a vectorized structure for the analysis. So it must be true. The output data types is also very important. Remember that we have all three outputs. One of them is with integer value, the trend class 0, 1, -1. The data type could be int. And for the rest, such as score and p-value, float suggested. Float 64. Float 64. There it is. Then go to the actually descriptions and check if there is if there is any important arguments that we missed or not. No, I think all of the important arguments settled very well. Okay, now you can save your code and then run the cell. Typically, it takes couple of minutes for such kind of data sets selected in this study. For a region of interest, the region of interest is in a national scale, a big country such as Iran, and the pixel size is 27 kilometer and more than 400 images for this area, and also this extent. It takes around, for example, less than 5 minutes, more or less. Yeah, and the code link is also available below this video on description box. You can compare your code with mine. If there is any problem, you can find the solution easily. And if problem still exists, feel free to reach me out and put your comments on my channel. So, and we should wait until the process is done, and then we can try for the visualization. Until then, I will pause the video and I will continue once the process is over. So, as you can see, the process is done after 1 minute. I was lucky this time. So, but sometimes it takes more. Make a new code and check the output. The first output is the change trend. Let's write the change trend and run it. As you can see, we have an array structure with values like 1 and 0. That makes sense. 1 means significant trend and 0 means, 1 means increasing, 0 means no trend based on these values. So, but the variable name still is mean air temperature. We need to call a new variable or make a new variable and rename the change trend. For example, change trend equals to change trend, rename, for example, the trend. Let's print the change trend. As you can see, the variable name converted to the trend. Do the same for the change score and change p-value. Change score, there it is. Get the change score first and rename it to score. And then change p-value or p-val here. Change p-val dot rename p-value. Let's run. So all variables created and ready for the visualization. To do the visualization, it is important to have matplotlib as an essential library for visualization. So import matplotlib.pyplot as plt, just like that. Run the cell, and now make a new plot structure. We want to have a one row with three columns. Actually, a landscape view with one row and three space or three plot space for each map separately. Same as previous example I showed you in the earliest stage of this tutorial. So let's start with fig and x from plt.subplot. Sets a dimension for the anticipated plot, for example, one row and three columns. Then the size of each plot. So this is experimental, and then you can change it if the values or numbers needs any modification. For example, the fixed size 8 and 3, for example. Okay. Then plt dot tight layout. The tight layout helping us to avoid actually mixing values of different plots as they are located next to each other. We want to avoid mixing their values. Okay, let's run, and now you can see we have a landscape view and with three plots. Okay, now I'm gonna plot the trend, score, and p-value actually in each plot separately. So now let's start with change trend. First, we want to need if there is any significant increasing or decreasing trend or not. So the x equals to longitude dimension, y sets to latitude dimension, and the next one is the axis. As we have three plots here, each plot actually addressed as one axis. Axis 0, axis 1, and axis 2. Axis 0. There it is. And let's run a code, and then you can see we have a binary image in the first axis that shows 0 and 1. If you go back to the trend class, you can see the number 1 means increasing and 0 tells there is no trend. Okay, that's a good news. There are some trends here and we can assess their intensity and their significance. Okay, the next axis, the axis number 2, we want to see the score values for this area. The change score dot plot x sets to longitude, y sets to latitude, and axis number 1, the second axis. To avoid any outlier impact on visualization, suggesting to set robust as true, just like this. Let's run a code, and now you can see the second layer or the score layer showing the intensity of changes. But as you can see, there is a kind of vertical stretch in the visualization, meaning that maybe the column size or the vertical size should a little bit decrease. For example, 2.5. Now it's a bit better. Yes. And prepare a better visualization. And don't and also some of the values and numbers mixing together, and no worries about this issue. In the next step I will show you how to remove the latitude and longitude to solve this issue. Okay, as you can see, the score values are really big, and we can also rescale them to a smaller value, because the smaller value is actually easier for interpretation. For example, as the values ranges around 10,000 more or less, now here we can actually do a multiplication for the score images. Multiply to 0.0001. Yes. Let's run, and this allows us to have the intensity image with a smaller value. It is easier for interpretation. Higher intensity, higher intensity means higher increasing. For example, in this area we have increasing temperature, meaning that, for example, this area, the intensity of increasing is more than this area. The intensity of increasing in this area is more than this, or the intensity of increasing in the northern side is more than the southern side. Yes, the intensity help us to get more information about the spatial variations and spatio-temporal changes. Now we want to see if these changes are significant or not. The change p-value dot plot x sets to longitude dimension, y sets to latitude dimension, and the axis number is number 2, and set robust as true. Let's run, and in the third axis now you can see the p-value. About the p-value ranges, it is important to know the pixels less than 0.05 are significant one that offers increasing or decreasing trend with 95% confidence. So if you want to highlight the values less than 95% accuracy, so, or significancy, let's set the maximum value in the visualized map to 0.05. There it is. And now you can see all the areas in which the pixel value is less than 0.05, meaning that this region, the detected trend and intensity in this region actually significantly accurate and reliable with a 95% confidence. So, as you can see, all the increasing trend in this area are significant because their p-value is less than 5% or they have 95% confidence. So how we can actually remove the latitude and longitude or axis values to avoid actually mixing these numbers. So it's very easy. Let's make a for loop. As we have multiple plots here, we can set a for loop very easy to apply a same function on each plot separately. So now for axis in AX, start this process. Axis dot set y label set to empty. Axis for all of the plots set x label to empty. There it is. Let's run. And now you can see the labels or the x and y labels are removed. If you want to get rid of the values, it is also easy to do. Axis dot set x ticks. Make a parenthesis and empty bracket. Axis dot set y ticks. A parenthesis and empty bracket. Now we have actually three plots showing the significance of spatio-temporal change detection for the region of interest. If you want to get export from the final map, just call the savefig from PLT. The output name is, for example, Mann-Kendall change with PNG format. The DPI dot per inches equals to 360 always offers a good quality for the output. And if you want to have all elements inside a frame, it is important to set BB box inches to tight style. There it is. Let's run. After a few moments, you will have a new PNG file in the left panel that easily downloadable here. Click on download, set an address and save it into your system. After a few moments, you can print it like this or open it up like this. You can see a high quality image that shows the trend, score, and p-value next to each other that you can use it for your research studies. I hope you like this tutorial, and also I tried to give you some insights about how to use Earth Engine data in the Python environment for machine learning data analysis. I hope you like it as much as I do, and thank you for your attention.